So in this video we are going to discuss about latches. So it is a storage element in a digital circuit. It can maintain a binary state indefinitely as long as the power is delivered to the circuit. So there are two types of gated latch. One is SR gated latch, and second one is D gated latch. Okay. So what is latch? It can store the binary value like 0 or 1 till the power is delivered to the circuit. So when the input changes, the output will change immediately. Okay. So let us discuss first. Let me discuss the SR gated latch. So the latch are very sensitive. As the input changes, the output changes. Here the S represent set and R represent reset. Okay. So this can be implemented using one as universal gate. So the universal gates are one as NAND and NOR gate. Okay. So first let me discuss the NOR based SR latch. So the circuit diagram looks like this. Okay, this is your NOR gate. Okay. So these two are your NOR gates. So what is Q? Q is nothing but this is Q bar. Okay, so R plus Q bar the whole bar. Okay, so this I can write it as R bar Q, right? So what is Q bar? Q bar is equal to Q plus S the whole bar. That is nothing but Q bar into S bar. Okay. Now let me write the truth table. SR. What will happen to my Q and Q bar? Okay, when Q, that is Q plus and inversion of this value. Okay, so when it is 0 0 0 1 and 1 0 1 1. So this is your first case and second case, and this is your third case, and this is your fourth state. Okay, so this is nothing but Q plus. Okay, so we take the equation, write it here. What is Q plus? Q plus is equal to R into Q, R bar into Q. And what is Q plus bar? S into S bar into Q bar. Okay, so we substitute here. So if Okay, so let me take q also here. Okay, if I take q, I will get 101, 110 and 111. So when q is 0, so when q is 0, I will get q plus as 0. Okay, so whenever the q is 0, the q plus is 0, right? So whenever r bar is 1, r is 1, q plus is 0, right? So 1 into 1, for the rest of the value it is 1. Okay, for q plus q plus the whole bar. So q plus the whole bar is what is the value? If s is 1, if s is 1, it will goes to 0, right? Because s bar is 0. Likewise, if q bar is 1, if q is 1, q bar is 0, right? So therefore it will goes to 0. Okay, so next the next condition is for this one. Okay, so 1, this is also 1, so we will get 1, and for this one, so this is 1 to 1 is 1. Okay, so you know this q plus and q bar plus is inverse of this one. So this condition is okay, this should be avoided, and this also to be avoided, and this two conditions should be avoided, right? Okay, is okay. So let me take this value. So 0 1. Now for this one, initial value is now it is 0, right? Now the present state is 0. If the present state is now it is 0, okay, it will goes to 0, and the next state will goes to 1, right? So for this condition, you can see if the present state now the next state value is 0, for the next value the present state will be 0, right? The next state will be, it goes to 0 and 1. So I can change this one to 0 to 1. Okay, similar way you can see for this value it is 0 now. We check this for 10. So for 10 it is for 100, for 100 s bar 0, so q plus is 0, and for q plus is 1 into 0, that is also goes to 0. Okay. So you can see when 1 0 0. Okay, so for 1 0 0, when for this condition, okay, so for this condition, q plus bar is equal to so 0 into 1, 0 into 1 is, so q plus bar, the whole bar is equal to 0. So this only, it will goes to the this value only goes here, right? So you can see, so this value only, it will goes to the next state, so it is 0 now. So so if it is 0 means this is 1 into what is r bar. R bar is for this condition, it is 1. So what my q plus will goes to 1. Okay, so therefore this 2 state is a valid state. Okay, becomes a valid state. So this I can replace this whole circuit as whole state diagram as SR q plus. So when 0 0 0 1 1 0 and 1 1. So for this two condition, when q is 0 and q is 1, so the q and for these two condition, okay, for these two condition, the q plus is nothing but q. Okay, so there is no change, that is present state is same as that of my next state. Okay, so the present state is same as the next state for 0 1 for the next two condition. So for whatever the value of q, the output goes to 0. Okay, that is the next state goes to 0. You can see. Next for 1 1, for 1 1, whatever the value of q, the next state goes to 1. Okay, so you can see for the 1 1, for 1 1, these two condition, the q plus and q plus bar are 0 0, that should not be happen. So that should not be, that case should be avoided. So this state is called as indeterminate state. You can apply in whatever way you want. Okay, since both the conditions are failing, you can't change, you can't go for the next state. Okay, so that is why I have given it as indeterminate state. Okay, so next let me go for the SR using NAND gate. So This is q this is q and this is q bar. This is your R and S. Okay. So now let me take what is q. Q is equal to R into q bar the whole bar. That is equal to, you can keep it like this itself. What is q bar? Q bar is equal to, that is q plus now. Okay. So that is equal to qs the whole bar. Okay. So if you want, you can write it as like this. Okay. So now let me write the truth table. S R q plus and q plus bar 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay. So what is q plus? It is 0, this is 1. So if R is 0, you will get 1. Okay. If R is 0, you will get 1. And this is 0, this is also 0, so you will get 0, 1. If q is 1 means our output is always 1. So 0 0 0. Okay. So let me write this. So if s is 0 means you will get the output as 1. So when s is 1, okay, q is 0 means you will get the output as 1, right? So 1, this is 0. Okay. So what are the case acceptable? This is acceptable, this is acceptable, this is acceptable, this is also acceptable. So these four conditions should be avoided. Okay. So this should be avoided, right? So these two conditions should be avoided, but let me assume why it is coming like this. Okay. So if I give 0 and 1, if I give 0 and 1, and the q and the q plus value goes to 1 1, right? 0 and 1, q and q plus value goes to 1 1. Now 1 into 1, it will goes to the next state as 0, right? So this 0, it goes here, and 0 into 0 0, and inverse of this one is 1. So I'm going to replace this 1 as 0. Okay. So now this condition is I have taken this condition. Okay. So for the next case, this is 1 and this is 0 1 0, and this is 1 1. Okay. So now you see here the 1 into 1 is 1 inverse is 0. So this 0 only it is going here. So 0 into 0 is 0, it will remains in 1. So for this one, this goes to 0. Okay, this goes to 0. So I have accepted these two conditions. Okay, so now I can replace the whole equation by SR q plus is for 0 0 0 1 1 0 1 1. So for these two conditions, this should be avoided. So it is in the indeterminate state. And for 0 1 q plus is in 0 only. For 1 0 it is in 1. For 1 1 it is in q bar. Okay, sorry, q bar, it isn't q. Okay, whatever the present state, it is nothing but so this is control has no change. Okay.